So again, dealing with confidence intervals give us a little bit more information, but they should confirm what we've already concluded. So they said the Minitab output for a significance test and a confidence interval based on the pineapple data is shown below. The test statistic and the p-value match what we got earlier, rounding up. So notice that here's our t statistic right here, so you have to know how to read this. This is my p-value, 0.008, which is what we just got. And then they also give you a confidence interval, which says that from here to here, which a confidence interval on the sample that we got is really telling us that we are, I think it's a 95% confidence, yeah, right here, 95%. So we're 95% confident that the true population mean of the pineapples, now that we put the irrigation system in, is between 31.255 in its weight and 32.616, which means that what we have, should fall in this range, which we do, but what it also is telling you that 31.225 is above this 31 that the null said it was 31. That means the mean was equal to 31, right here, the mu, and since 31 is not in my range, it would have happened before the 31.255, we would know that we would reject this, that this is not true, and that the alternative is, and that's really what they're telling us here. So they explain that interval captures the mean, and then as proportions are linked, there is a link between a two-sided test at significance level, alpha, and the percent confidence interval. So an alpha of 0.05 is a 95% confidence interval, and they're just going through that for you. The connection between two-sided tests and confidence intervals are even stronger for means than it was for proportions, because both inference methods for means use the standard error of the sample means in their calculations. It doesn't change, right? Remember, with proportions, they use the assumed null. Notice that here in the t statistic, we used the standard error, and we did it here and in the confidence interval. So they're actually more related than proportions are. And they tell you why. Make sure you know that when the two-sided test, significance test rejects H naught, right, then the confidence interval will not contain the hypothesized mu. So it's kind of a little bit of a relationship there. And when the two-sided significance test at alpha fails to reject the null hypothesis, then the confidence interval will contain it. So just knowing and understanding that relationship with confidence intervals. Now, the only thing left that we have to do in this section is dealing with paired data. And so the big deal is that you'll have two sets of data. Paired usually deals with pre and post information. So technically it comes from two sets. Paired is usually like pre and then post. Okay, it's the two things, before and after, maybe looking at someone's weight loss or something like that. Because even though it's two different sets of data, we actually simplify it down to one set of data, because we'll do something like the pre minus the post, and you really get like net loss, potentially. And then that column is what you'll do your data on, and that's only a one sample. We no longer have two samples when we do paired data. So I don't want you to think when we do paired data that it's actually two sample testing. It's still only one sample, because we do the testing only on the one sample after we've found some type of relationship between them. So it tells you that when we're going to do comparative studies for more convincing than a single sample investigation, they tell you that we end up with paired data. All right, the differences are called paired T procedures. Right, and then here is a practice problem. It says, researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which the subjects took the caffeine and the placebo was randomized. At the end of each 2-day period, the test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. So here's our subjects, and this is their depression number when they are on caffeine and when they were not on caffeine. And what they did is they just found the difference, the placebo minus the caffeine, right here. So this technically is all the data that we're actually going to be doing our calculations on. Now what happens here is that we're going to do our state, okay, and when we're doing it on the difference, right, it's really always going to be the same null and the same null, which the mean difference is 0. If it doesn't have an effect, if caffeine doesn't affect their depression, then that means when I subtract them, I'm going to get a 0 score right here. And so if the average is 0, that means that there's no difference between having caffeine and not having caffeine on their depression. So anytime I'm doing a paired t-test on the means, my null is always set equal to 0. All right? I want to make sure that you understand that it's set equal to 0 and why it's set equal to 0.